doing so good today. Okay, so which ones out of, so we'll just start at the first one. Is the first one a rational function, a rational expression? Yes or no? Yes, good. Because x squared is a polynomial, and 4x plus 1 is a polynomial. Great. What about the second one? The question is 3 a polynomial? Is the number 3 a polynomial? Is the question, right? It doesn't have a variable. Can I have a polynomial that doesn't have a variable? Well, the answer is yeah, because the variable would be to what power? 0, right? So it's x to the 0th power, which is okay. So it's still a polynomial. So this still counts as a rational expression. What about sine of x? Is that a polynomial? No, sine of x is not. So no, trig functions are not polynomials. What about the fourth, what one? I almost said third one. The fourth one. It's just x squared plus 6x plus 5 over x squared plus 7x minus 9. Yes. It's in fraction form. It's got a polynomial in both the top and the bottom, so it is a rational function. What about the square root of x plus 3? First of all, it's not a fraction, so it can't be, right? And second of all, this x is underneath the square root, so it can't be a polynomial. So it fails both definitions, both parts of the definition. And what about the last one? Yeah, because 5 is still a polynomial, so it's still a rational expression. Okay? Awesome. Okay. Simplifying rational expressions is very much like reducing fractions. All factors that are common in the numerator and the denominator are eliminated or canceled, right? We're making ones. So you guys know how to simplify fractions. But I kind of want to talk about this little which one is correct and why question. It says 2 plus 3 equals 3. It canceled out the 2 plus 3 divided by 2 equals 3, and 2 times 3 divided by 2 equals 3. Which one is correct and why? So think about it, come up with an answer, or try to. Oh. Nice, Jess, by the way. Yeah. So if I do it mathematically, if we do this mathematically, right? Order of operations says I do, and it's in fraction form. Order of operations says I do the top, everything on the top and everything on the bottom before I divide, right? So if I do this one first, what's 2 plus 3? 5. And is 5 divided by 2 equal, does 5 divided by 2 equal 3? No. Okay. So because it's this add sign is here, I can't cancel out with an add sign in there. I can only make cancellations if there is a time sign, because 2 times 3 is 6, and 6 divided by 2 is 3. Okay, does that make sense mathematically? So adding, it doesn't work if I have to add something, because they don't add to be the same thing. Is that okay? Okay. Help me. All right, so once we get in here, even with variables, that holds the same. So I can't say, what I mean is, like, if I have x plus 2 divided by 2, and then I have 2x divided by 2, I can't cancel those 2's out there because I don't know what the value of x is. I can't say that equals x. That's a big no-no, okay? So I can here on this one, because I know what that is. 2 times x, I can say that equals x.
Is subtraction under the same rule?
Subtraction and addition are same rule, okay? Yes, nice question. Okay, so let's look at, we're going to just review before we get in. So, how do I want to say this? When we start doing rational functions, basically what we're going to do when we multiply and divide these is we're going to factor. And I know it just sounds counterintuitive because factoring is unmultiplying, right? But we're going to factor. So we're going to do a quick review of factoring before we get to actually doing the rational, start multiplying and dividing and really getting into rational functions. So we're just going to factor today. And then do a little bit of simplifying with that, okay? So how can I factor? Okay. 8x to the fourth minus 4x cubed plus 10x squared. What is in all three of those terms? I think I need to get rid of the x's to see if I can actually factor it first. What can I take out of 8x to the fourth minus 4x cubed plus 10x squared? And what else? 2x. How many x's out of each term can I take?
Would it just be 1 because there's a 2 here?
Well, I have 4 x's in this term, and I have 3 x's in this term, and I have 2 x's in this term. So what's the most x's I can take out of all three terms? 2. Yeah, 2, good. So I can take out 2x squared out of each term. So if I take 2x squared out of 8x to the fourth, I should get left with 4x squared. So remember, when I'm factoring is unmultiplying, right? So if I distribute this back out, I should get the same answer as my original. Okay, so, and then I take 2x squared out of 4x cubed. That should be negative 2x. And then 2x squared out of 10x squared should be plus 5. And there's no way that factors to anything else. So that we're done. This is just factoring out a term like this, and that's done. We're done factoring. That's all that can be factored out. Okay, so I want you guys to go ahead and factor the next 2 if you can. Just factor. Okay, what can I take out of A? What's the common factor in A? 3, and then what's my common variable factor? 3x, beautiful. Okay, so what can I take? Nice, Jess. So if I take 3x out of 3x to the 6th, I should get left with x to the 5th. Because 3x times x to the 5th is 3x to the 6th, right? Yeah. And then if I take 3x out of negative 9x squared, I should get left with negative 3x. And if I take a 3x out of 3x, what should I get left with? Yeah. Thanks, Brooklyn. 1. Because remember, when if I just multiplied this back out, I want to get the same thing. I know that some people would have said nothing and not put the 1 there, but then if there wasn't 1 there, if I multiplied it back out, I wouldn't get the 3x at the end. So there has to be a 1 there. Okay? Nice job, you guys. And then B, a little bit harder because we have more variables. We have 2, right? So what's the most x's I can take out? Nice, Gage. The most x's I can take out, I have x cubed, x to the 4th, and x to the 5th. So the most x's I can take out is x cubed. Okay? And then I have y squared, y, and well, I have a y by itself, so y is it, okay? So if I take those out, and I have x cubed, I think I'm going to get left with y here. So take out all the x's and 1 of the y's, okay. Plus 3 times x plus 5 times x squared, y squared. Yeah, that looks right. Nice, Jacqueline. Questions? Not too bad? Okay. So we're going to talk about factoring quadratics. Right, this is using the little cross, I showed you how to use the X method to factor, or however it is that you guys learned how to factor last year. I used the little, I think I showed it to you guys, the little this, where you need to multiply to be negative 15 and add to be 2. I need two numbers that multiply to be negative 15 and add to be 2. What two numbers multiply to be negative 15 and add to be 2? Negative 3 and 5. So this factors to x minus 3 times x plus 5. Done. That's it. Okay? Slide. And then for number 2, same thing. I need two numbers that multiply to be 24 and add to be negative 10.
Is it -6 and -4?
It is. Nice page. So x minus 6 times x minus 4. Done. Okay, so go ahead and do the next 4 problems, please. Go ahead and do this. So A, I need two numbers that multiply to be negative 9 and add to be negative 8. So it's negative 9 and 1. So x minus 9 times x plus 1. B, similar thing, two numbers that multiply to be 9 and add to be negative 6. So negative 3 and negative 3. So you can write this one two different ways. I could write this as x minus 3 times x minus 3. That's great. Or I could write it as x minus 3 squared. It doesn't matter. Either one is correct. It doesn't matter whichever way you prefer to write it. Okay? C. So this one's a little different. I still want two numbers that add to be negative 9, but notice I'm missing the x term, so they need to add to be 0. Okay, so if I'm doing my little cross thing to help me factor, so that would be negative 3 and positive 3. So this will be x minus 3 times x plus 3. And then the last one, multiply to be 100, add to be 20. So x plus 10 squared. Okay. All right, so here we go. Now we're going to still factor quadratics, except now a is not equal to 1. And I know that we went over how to do this. It's a little more complicated, right? And for these ones, how I factor them, I still need the two little things up here. I use the multiplication box where I'm going to unmultiply them this way. So I've got 3x and negative 8 down here. I still need two numbers that are going to add to be 2, but now they multiply to be a times c. So 3 times negative 8 would be negative 24. Is that right? Yeah. So what two numbers multiply to be negative 24 and add to be 2? 6 and 4 again? 6 and negative 4. So now I'm going to factor so this is the answers inside my multiplication square, right? So now I want to factor my rows and my columns to get what I'm actually multiplying together, which is going to be my answer. So what, oh my gosh, what goes into both 3x and 6x? 3x, right? Okay, what goes into both negative 4x and negative 8? Negative 4, good. What goes into 3x and negative 4x? X. And what goes into 6x and negative 8? 2. Beautiful. And you can see if you got the right answer because x times 3x, oh, sorry, this should be 3x squared. My bad. And x times negative 4 is negative 4x, 3x times 2 is 6x, and 2 times negative 4 is negative 8. So my answer is 3x minus 4 times x plus 2. Okay, you guys, I am so sorry. Okay, so another way you can think about this, Jess, is... Oh, instead of, let's not put that there. Instead of doing it the box way, I can say, what happens if I kind of split this 10 up and I say, I still want to do this, and I still want to say what adds to 10 and multiplies to be negative. Oh, is that going to work? Is there one that does that? Adds to 10 and multiplies to be negative 30? There's 15 and 2, and 10 and 3. There's nothing else that multiplies to be 10, is there? 10 and 3 and 15 and 2. Oh, 5. But that still doesn't add to be 10. 5 and 6. Huh. Of course, 5 and 6. Wow, I'm doing really well today. So maybe this one doesn't factor. Let me think about it this way. There's 5x and x, right? So there would be 1 and 6. I'm going to do the guess and check method, by the way, and I don't recommend this, but 2 times 3. 15 times 2, 10 times 3. Yeah, this one does not factor. So that is not, how does this not factor? Okay. I wonder if it's a typo that I didn't change. Now that's going to bug me. I'm going to have to write myself a note. Let me write myself a note. Fix 6.1. Okay. So I'm going to do one of these ones so I can talk about it. Okay, this one was work. Okay, so think of it this way. I still need two numbers that add to be 12 and multiply to be 4 times 5, which is 20. So when I teach this, the cross method, this is A, it has to multiply to be A times C, and A is 4 and 5 is C. Most of the time we don't have to do this because A is 1, right? So we don't have to think about this one, right? So what adds to be 12 and multiplies to be 20? Anybody? Oh, on that, yeah, that one it just didn't work. Yeah, so sorry. I'm serious. It must have been a typo, Jess. Sorry about that. So what two numbers multiply to be 20 and add to be 12? 10 and 2. Okay. So I can, instead of doing the box method, also you can also do it this way. I can rewrite this as 4x squared plus, I want to kind of be strategic about write this, plus 2x plus 10x plus 5, okay? And then I'm going to factor this, and I'm going to factor this, factor by grouping, okay? And then what can I take out of 4x squared and 2x? Well, I can factor out 2x, and that should give me 2x plus 1. And out of my second group, I can factor a 5, which should give me 2x plus 1. Look, notice now I've factored it down, so I have a 2x plus 1 both in each term, yeah? So now I can factor out a 2x plus 1, and that gives me a 2x plus 5 left. So there's another way to do it, which is basically the same thing as doing it in the box method. It's just not quite as clear to some people. Okay? Does that help a little bit? Okay. Chris, okay. So if you guys will go ahead and work on, and I don't care what method you do it, or what method you use to factor the next 3 with, if you'll go ahead. So for B, I'm just going to write down the answers, and if you guys need me to go over them, I will, but let me know. So B would be 5x plus 9 and 5x minus 9. Beautiful. C is going to be 3x minus 4 and 2x plus 3. I think that's right. Yeah. Okay. Let me make sure. -8 plus 9. Yeah, that's it. Okay. And then D is 7x minus 4 and 7x plus 4. Is there any questions? Does anybody have any questions on those? Are we okay? Serena, are you okay? Okay. So now we're going to take that factoring skills and we're going to simplify rational expressions. Okay, so we just have an expression and it says, remember, we cancel common factors only. So the first thing we're going to do to simplify is factor. That's pretty much all we're going to do is factor, 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 factor. Okay, so we're going to factor, then we're going to cancel anything that's in common, and then that's our answer. Okay, so we're going to factor the top, we're going to factor the bottom, cancel out or make ones. I hate the word cancel because we're making ones, right? Because if there's nothing left in the top, what do I put in the top if there's nothing there? Well, I made a 1, so I put a 1 there. So that's what we're gonna do. So out of the top, what can I factor out of 2x plus 6? So what can I factor out of 2x plus 6? 2. So if I take a 2 out, I get left with x plus 3. And then in my denominator, what multiplies to be -6 and adds to be 1. Well, I'm pretty sure that's 3 and -2. So I've got x plus 3 and x minus 2. So I have an x plus 3 in the numerator and in the denominator. That makes a 1. So that's my common factors. That goes away. And what I get left with is 2 over x minus 2. And that's my answer, done. Not bad, right? Just factor and cancel. That's it. Okay, so we're going to do the same thing for number 2. We're good. Can I go on? So give me 2 numbers that multiply to be -12 and add to be -1. -4 and 3. So x minus 4 times x plus 3. All over 2 numbers that multiply to be 15 and add to be 8. I'm pretty sure that's a 5 and 3. So x plus 5 and x plus 3. So my common factors are 1 in the top and 1 in the bottom of the x plus 3s. So I get left with x minus 4 over x plus 5. And I'm done. Okay? Any questions? Zoomers, are we okay? Awesome. Okay, number 3. Oh, okay. So my top is going to factor to, let's see, 3x and x. Oh, we got a -3 and a positive 3, negative 9 minus 3 is negative 6. Okay, beautiful. And then in the bottom, let's see, we're going to have a 2x and an x. I'm thinking that this is not the right factor. I mean, I know it works, but I'm thinking that maybe this is 9, negative 9, and plus 1. I think that works better. Because I'm thinking this is negative 8 and plus 1. Because 8 minus 2 is 6, right? Yeah. Okay, so the plus 1's go away. And I get left with 3x minus 9 over 2x minus 8. Oof. That was a tricky one. Okay, so you guys try on A, B, and C. We're doing the same thing. So the first one, I'm just going to go ahead and start. You guys can keep working on the third one if you need to. So I've got 3 times 2x minus 1. And then I've 16 x squared minus x minus 20. Over 6 times x 5 plus 4. So on the second one, I've seen some people multiply the 2 through in the denominator. You don't have to. You can leave it factored out. So I can leave it as 2 times x minus 5. I don't have to multiply it back together if I don't want to. Okay? So I can just leave it just like this. Or you could write it as x minus 4 over 2x minus 10. Either one's acceptable. Okay? Either one is right. And then the last one, x minus 3 times x plus 2. Minus 2. Minus 3 over x minus 2. Okay, questions? Are we okay so far? Not too bad? Right? So I think, oh, it's just more practice for you guys. Awesome. So keep going. We've got 6 more problems. I'll make it bigger so you guys at home can see it better. Okay, I'm going to go over these, and then you'll have a few minutes to work on the Delta Math, which is, oh my gosh, just like these, right? You're doing exactly the same thing in Delta Math. Okay, so x plus 3. Oh, can I do this? Undo it? Oh, good. I drew my line through the wrong one. Okay, x plus 5 over x plus 6. Oh my gosh, they're so loud. X plus 3 times x plus 4 over x plus 3 times x plus 2. Equals that. And then the second one, I factored a 2 out of the top, and I got x squared minus 4. So I get 2 times x minus 2, x plus 2. And the bottom factors to x minus 2 times x minus 2. So I'm going to get 2 times x plus 2 over x minus 2. I don't need to have that there. Questions? Are we okay with those? Awesome. If you guys don't ask questions, I'm just going to keep going. So x plus 4 all over x plus 4 times x plus 2. Those go away. Now, I made a 1, so that means I have a 1 in the numerator and x plus 2 in the denominator. That's why thinking about not canceling them out and actually making 1s is a little better, because if you don't have anything left in the top, you know that's at least a 1. Okay? So if I factor 4 out of the top, I get x squared minus 1. So this factors the 4 times x minus 1 times x plus 1. And if I factor 2 out of the bottom, I get x squared plus 2x minus 3. So x minus plus 3, x minus 1. So those go away. This becomes a 2. And I get 2 times x plus 1 all over x plus 3. Okay, and then last but not least, 2x plus 3 times 2x plus 3 all over 2x plus 3 times x plus 1. X equals 2x plus 3 divided by x plus 1. Okay, there you go. Answers for all of them. You have about 14 minutes to work on, 17, 18 problems in Delta Math. Please make sure you're getting your work done. Also make sure that if you want the extra credit, you can go in and do that form for the extra credit. Every time we do a lesson, you get extra credit if you go in and do that. Do you know where it's at? You're looking at me like I'm crazy. Let me push pause first.